Welcome back. In this video, we're going to take another look at our Maduino board that we covered the last time. Again, this board has the SIM7600 module, which means it has both GPS and LTE connectivity. And we're going to take a look at power consumption. Before we look at the code, let's look at the different power saving modes we have. So first of all, we have the board itself, or the microcontroller unit here. And the MCU has three different modes. We can use a regular delay call, which works. Using the low power library, which we'll see, we can have sleep or deep sleep mode. Now the module itself, the SIM7600 module, also has various low power states. It can be on, which isn't low power, but it has full feature. It can have minimal feature or minimal functionality, and then it has off. During this video, we're going to take a look at various combinations of MCU modes and SIM7600 modes and see which mode works the best. Just to visualize what's happening here is on regular intervals, the GPS data is collected and the API is used to upload that data. And then the module, we're going to put it to sleep. And then it's going to wake up and repeat that same process over and over and over again. And so what we're trying to do is minimize the power consumption from the unit during these time periods. So if you look at these patterns here, we can't really do much about the GPS and the API time period. That time is, we're trying to make that as efficient as we can, and we're doing that by bundling multiple GPS points up into one single API call, and that's the best practice there. What we're focused in on this video is what's happening here during the sleep period. During this period, we want to minimize the power consumption. And just a quick refresh before we get started here with the content for this video. The last video covered a lot of the details of where we're at, but I just want to refresh just a little bit if you haven't seen that video. Working with a Maduino Zero board, it does have a SIM7600 module on it that you can see here that adds GPS and LTE connection. And so that's the board that we're working with. One of the things where we left off, and the thing that we're going to fix today, is if you look at the code, which is in GitHub, so all the code, I've actually I'm just looking at the tag that I left for version 1, which is here, and you can see where we left off on the main CPP code. The last time I want to look at just at the loop. The reason I want to look here and focus here is because this is a bit inefficient, the way it was implemented, but it was step 1 to getting this thing working. There's a delay here of a second at the bottom, and so every second this loop is run, whether it needs to or not. And the reason that's inefficient is because up here is when the GPS is collected, and the GPS period, maybe that's only every 10 minutes. I want to collect a GPS point every 10 minutes, and maybe I want to cache those GPS points and send them every 20 minutes. And so this wake up call down here it's a little inefficient. It causes the board to wake up. And so we're going to try to fix this today. We're going to remove this delay and see if we can't do something that's a little more power efficient or low energy. We are using Visual Studio Code for the development. One library we're going to need for this is the Arduino low power library, which allows us to set the board into various low power states. And so to install this, the installation is pretty simple. We copy and paste this code, and we're going to drop it in our platform IO, and I've already done that. You can see it here. And once you've dropped it in to your Visual Studio Code, it'll automatically load the library for you. So let's review the changes to the main CPP code. At the very bottom, I'm not going to cover most of the stuff at the top. It's mostly the same. You can look at the GitHub repo if you want to see the differences. But at the very bottom, you can see I have this new call. This is where the delay method was, and we replaced that by a call to a sleep class. All right, so let's take a look at this sleep class. And again, we're using object-oriented programming to encapsulate all of the sleeping functionality into one class here. We instantiate that class up here at the top, and the only thing we pass into it is we pass the instance of the hardware. So let's look at the declaration of this sleep class. And right away you can see there it has groups of 3 public methods. Each group of 3 focuses in on one of the different MCU modes and module modes. So in this top group of 3, the SIM76 module is kept on, and the MCU is varied between its delay, just a normal delay call, or we're going to use the low power library sleep method, or the last one is the low power library deep sleep method. The next three varies the MCU over those three methods, but now the SIM7600 module is set to its minimum functionality mode or low power mode. And the last three vary the MCU over those three different states, and the module is turned off. So the plan is to use each one of these and measure the amount of power that's consumed by the module. There are a number of private methods here, and we'll look at each of these as we move into kind of the implementation of this. So let's look at the implementation. The implementation, the constructor, it takes an instance of the hardware class, and we're passing it by reference, and then we're just kind of setting it there. And there's these two helper integers that we're going to use later on, but for now we're just initializing those to 0. And then we can see our first three here. So this is where the module's kept on, and the MCU is varied between just delay, sleep, or deep sleep. The next three we're going to see are where the module is set to low power mode, but the MCU is went from delay, sleep to deep sleep, but you can see the module set to minimum functionality mode, and then it's woke up. And it's set to minimum functionality, and then it's woke up again. And so that's the next set of three. The last set of three you can see are following kind of a very similar pattern, where the MCU is varied between delay, sleep, and deep sleep, but here we're turning off the module and turning it on in between. So on or off, and then on, off, and then on. And now that we've gone through all of these public methods, let's look at the private methods that really do all the work here. And we're going to focus in on one of the MCU ones, and then the other two MCU ones will kind of follow the same pattern. The first one is MCU delay, so we're simply calling delay. This is no better than the previous version of the code that we developed in the last video. The only difference is we're sandwiching this call between pre-sleep and post-sleep. And we're going to talk about what pre-sleep is and post-sleep as we look at the implementation, but for now, pre-sleep computes an adjusted sleep period, and we're going to delay for that adjusted sleep period. And we'll talk about what that means in a little bit, as it'll make more sense later. Let's look at the MCU sleep call. This version, we are using the low power library. They are doing a low power library class, and we're calling the sleep method. One thing that I did notice was if I didn't end the serial USB hardware connection and start it up after, then my code would hang up in this area. And so I end the serial USB connection and I start a new one after the sleep is completed. So during this sleep period, there's no output going on. The MCU is asleep anyways. But if you don't include these, your code will hang. Again, this code is sandwiched by a call to pre-sleep and post-sleep. The MCU deep sleep is very similar. The only difference is it uses the deep sleep method instead of the sleep method. So those three really kind of control the MCU process, or the MCU processor, and what mode it's in, whether we're choosing a call to delay, or we're calling sleep, or we're calling deep sleep. Let's look at the functions that control the module. These two set the module in minimum functionality mode and restore it to full functionality mode. And they follow the same pattern. We'll look at this one first. The first thing I do is I capture kind of the time before I do anything on the hardware. And then I take the difference of the time after to kind of see how long it takes. So when I'm all done, MS before sleep holds the number of milliseconds that it takes this process to happen. And so here I'm using the hardware class that I instantiated this with, and I set the module in minimum functionality mode. Down here, again, I'm tracking the time. So when I'm all done, MS after sleep will hold the number of milliseconds it takes to restore the hardware to full functionality mode. And again, here I'm just using the hardware class to set the functionality mode back to full functionality mode. And because it was essentially off, and I have to reconfigure the module when I turn it back on. So let's look at this in detail here. This is a pretty easy call. I'm calling I'm using my command helper, and I'm sending this command to the hardware, and I'm expecting this result. I do wait 5 seconds for this. So I encourage you to look at cfun command, the ATCFun command, in the PDF that we discussed the last time. And you can see it has different values that you can set. 0 is for minimum functionality mode, and 1 is for full functionality mode. So this is the function to return it to full functionality mode. So sleep uses these two methods to set it in minimum functionality mode and to return it to full functionality mode. And configure module is, I think we covered this the last time, but if the module's on, then we set it in verbose mode. But down here you can kind of see what we're doing is we're making sure that the radio's on, we're getting the model identification number, and we're setting up our different endpoints. So we're setting the APN and everything. We covered this the last time. So let's look at the next two. This is turn the module off and turn the module on. And these two follow the same pattern. Again, I'm computing how much time it takes for me to actually turn the module off, and I'm computing how much time it takes to turn the module back on. And we're going to see how those are used in a little bit. Let's look at the actual module turn off and the module turn on code. This is again a hardware class. The module, if it's on, I set the power to this key low, and then I send the CPOF command. This is power off, essentially, to the module. There's a long delay here, but again, this delay and this one are all taken into account by this computation. And so this will be at least 25 seconds plus whatever time it took the module to actually turn off. Turn the module on is very similar. If we look at the turn the module on command, if it's not on, then I set essentially the low power key to high. I wait for it to start responding to AT commands, and once it's done that, and then I can return true. And again, after the module's been off, I do have to configure the hardware again. And the last two things we'll look at are the pre-sleep and the post-sleep. Again, so pre-sleep computes this adjusted sleep time using how long it took to set the module up beforehand, or set it to minimum functionality mode, or turn it off, and also how long it takes to turn it back on. So we're trying to throttle and adjust our sleep time to the appropriate number. So if you ask me for 60 seconds and this took 25 and this took 10, then that's 35. I'm only going to sleep for like 25 seconds here. There is some serial output here, before it goes to sleep, and just kind of telling us what the actual the interval you asked for, and then what I'm actually adjusting for, and then it says good night. And then remember, after it does this, I go into my sleep mode, and then I wake up, and then I do post sleep. And post sleep is, it's just simply, hey, I'm awake. That way, visually, when you hook this thing up to your debug mode, you can see what's happening here. So that's a pretty simple review of the sleep class and all the methods. Probably when you implement this yourself, you're going to pick one, and you may not even have to implement the rest. I implemented the rest because I wanted to measure, again, the power savings in each different mode. All right, let's take a look at some of the data. Before we do that, though, just a reminder, we have configured the hardware to post to this website, and we'll look at that in a second. One of the other things that I've adjusted is the number of API points in each payload. I've set that to 1. So essentially every single time the GPS wakes up to take a point, there will be 1 point in the cache, and then the radio will wake up and send that point to the API. I could cache these, but just to be consistent, I've had that always set to 1. So every time the GPS wakes up, I always send that 1 point. I did two versions of this test. I did a 1-minute version, so every 1 minute wake up, collect the GPS point, send it, and a 10-minute version. So every 10 minutes wake up, collect the GPS point, and send it. And we'll see the power differences between both. And just a reminder, this website, it looks like this, and every single time it posts a point, you can see the payload. And I'm grabbing this date timestamp, so I know what current time it is, and I can scroll to the bottom of these and find out when the very first one was, and so I can use that in my spreadsheet, and you'll see that in a second, how I use those two time differences to compute how much time that the unit's been powered on. And that's a rough estimate. It takes about maybe 20 seconds or so, 30 seconds or so for it to grab the initial point. So it's not 100% accurate, but it's accurate enough. So let's look at some of the results here. This is a spreadsheet, has 2 tabs. And by the way, this spreadsheet is in your Git repo. So the power consumption spreadsheet, if you don't have a Mac, this is a numbers document. If you do have a Mac, you can open it up. If not, you can open up the PDF. So let's take a look at the numbers here. The numbers, I have 2 tabs. I have varying the different sleep modes, and then I have varying the cycle time. And so we'll see results. Let's look at the sleep modes first. The sleep modes are at the top, and so you can see the MCU is using the simple delay, and the module's kept on. And the module's kept on for all 3 of these columns. And then I'm starting to vary the module over these 3 columns. And so we'll see kind of those differences. Here's the timestamps at the bottom, so I just copied and pasted the timestamps in. This is a computed field then, so it takes the differences and it finds out how long it's been on. My process would be is I plug the module in with the code that I want it to run. I let it run for 6 hours or so, and then I grab the data and I put it into the spreadsheet. So this time, 2,110 seconds, it used 286 milliwatt hours. And so this is just a copy of the seconds from the bottom, how many GPS points. So I'm just going to focus in on this column right here. This is kind of the power consumption column. This is how many milliwatt hours per hour I'm using. And so this is a per day value. And so to get this module to run, I would need to supply this thing for a 24-hour period, a battery that had at least, say, 1,200 or 12,000 milliwatt hour capacity battery. So that's kind of a review of what the numbers mean. So if we look at this, the lowest number, so here's delay, MCU delay, had this number. I put it in low power sleep mode. It did go down a bit, not a lot. And we'll talk about why this didn't go down a lot here in a second. And then deep sleep mode, you can see it actually was increased a little bit. So I think this is probably within my noise margin, and I wouldn't worry about that too much. The reason we don't see a lot of differences in this particular example is because I'm waking up every 60 seconds. The sleep interval, remember originally the green box, is really super tiny. So most of the consumption of power is happening kind of back to back. So it's not really getting a fair amount of sleep. It's continually consuming power in the GPS and API mode. And that's why these numbers really don't vary a lot. We're not saving a lot of time by changing the different modes every 60 seconds. And same thing here. We can see if I put it in simple delay mode, the MCU, and I switch it between low functionality and the module off, I'm not really getting the savings that I wanted to see. And so this first version kind of proved to me that if you're really going to sample every 60 seconds, so if you're going to sample at a quite often rate, then just keep your MCU on and keep your module on. You're not going to save a lot of power by switching to one of these modes. Now, so where you start to really see kind of a benefit of these low power modes is when you switch to not sampling every 1 minute, but maybe every 10 minutes. For example, this is a 10-minute interval, and you can see the comparison between 1 minute and 10 minutes here. So just using simple delay, and I kept the module on, the power consumption went from 487 to 350. So it went down. So now I'm starting to see, the delay is, it's not the lowest power, but it is using less power. And so sampling every 10 minutes is I'm saving some power. Here's another one where I went from using the simple delay. And by the way, the MCU in all of these is the simple delay, and I'm changing the module, how the module behaves. I'm switching to low functionality mode, and you can see sampling every 1 minute. I went from about 550 to, if I sample every 10 minutes, down to 345. So this is comparable to that. I'm not sure, it's probably in the noise margin. I'm not sure I gain much just by switching to low functionality mode here. In the final 2 columns, I'm turning the SIM76 module off in between samples. So here you can see every 1 minute, and here's every 10 minutes. So it's a comparison of 550 milliwatt hours to 170. So this is a pretty big difference. And so sampling every 10 minutes, it's worth it to switch that module off. And let's summarize by saying that choosing the sleep mode that's best for your application depends upon the scenario that you're in. If you're unlimited power, then there's no probably need to conserve anything. So just keep the MCU on, use the simple delay, and keep the SIM76 module on. The other scenario is if you're limited power, or if you're collecting GPS data at kind of a lower rate. In that case, there's probably some benefits to using the MCU in deep sleep mode and turning the SIM7600 module off. So hopefully that helps. If you have any questions, leave a comment below. I try to answer questions. All the codes in GitHub, and we'll see you next time.